NEC Section 300.13b addresses equipment grounding conductor continuity. This section states that the equipment grounding conductor, abbreviated EGC, shall be continuous throughout its entire length and shall be connected to both the equipment it serves and the grounding electrode system. The code itself does not specifically dictate which size equipment grounding conductor to employ when you have a situation with mixed wire sizes. What it emphasizes is that the equipment grounding conductor must maintain continuity and that it must be connected to both the equipment it serves and the grounding electrode system. Given that the power source, the switch leg, and the counter plugs are all interconnected to the same grounding electrode system, the NEC technically permits the utilization of either the number 14 or the number 12 equipment grounding conductor for all the devices. However, it's important to delve a little deeper into best practices. While the code allows flexibility, a practical recommendation emerges. The general recommendation, and this is not a code requirement but a suggestion for enhanced safety and best practice, is to maintain consistency in the size of the equipment grounding conductor for all devices situated on the same circuit. In the scenario you've presented, adhering to this recommendation would mean opting for the number 12 equipment grounding conductor simply because it represents the largest size among the available options. Why is this the preferred approach? Firstly, using the larger conductor ensures that the grounding path has a lower impedance. Lower impedance means that, in the event of a fall, the ground fault current will be higher, leading to quicker operation of the overcurrent protective device, such as a circuit breaker or fuse. This faster response minimizes the duration of the fault, reducing the risk of electrical shock and fire. Secondly, the number 12 equipment grounding conductor has a greater current carrying capacity than the number 14. This means that it can handle larger fault currents without overheating or becoming damaged. Thirdly, from a practical standpoint, using the larger wire size across the board simplifies the installation process and reduces the chances of errors. It eliminates the need to constantly switch between different wire sizes and helps maintain a consistent level of quality throughout the electrical system. Now, let's consider the implications of using the smaller number 14 equipment grounding conductor instead. While the code permits it, it's generally not advisable. The smaller wire gauge offers less protection in the event of a ground fault. The higher impedance of the number 14 wire can impede the flow of fault current, potentially delaying the operation of the circuit breaker or fuse. This delay increases the risk of electrical shock and fire. Additionally, the number 14 wire may not be able to handle the full fault current, potentially leading to overheating and damage. To summarize, while the NEC provides some latitude in selecting the equipment grounding conductor size when dealing with mixed wire gauges, opting for the larger size is the recommended approach. It enhances safety, improves the performance of the grounding system, and simplifies the installation process. In your specific scenario, using a number 12 equipment grounding conductor for all devices connected to the same circuit is the best practice. It's important to note that this recommendation is not a substitute for a thorough understanding of the NEC and all applicable local codes. Always consult with a qualified electrician or electrical inspector to ensure that your electrical work meets all requirements and is safe. Additionally, proper grounding techniques are essential for the safe and reliable operation of any electrical system. Always follow the manufacturer's instructions and use approved materials and methods. Here are some additional considerations. Firstly, inspect all equipment grounding conductors for damage or corrosion. Replace any damaged or corroded conductors immediately. Secondly, ensure that all connections are tight and secure. Loose connections can increase impedance and reduce the effectiveness of the grounding system. Thirdly, test the grounding system regularly to ensure that it is functioning properly. Use a ground impedance tester to measure the impedance of the grounding path. Fourthly, document all electrical work, including the size and type of equipment grounding conductors used. This documentation will be helpful for future maintenance and troubleshooting. And lastly, stay up to date on the latest changes to the NEC and all applicable local codes. Electrical codes are constantly evolving to reflect new technologies and safety concerns. So remember, the primary goal of an equipment grounding conductor is to provide a low impedance path for fault current to return to the source. This low impedance path facilitates the quick operation of overcurrent protective devices, minimizing the risk of electrical shock and fire. When mixing wire sizes, always prioritize safety and choose a larger equipment grounding conductor to ensure that the grounding system can effectively handle fault currents.